Hey, this is George Woodbury from College of the Sequoias in Visalia, California, and here I'm going to work through the problems from our Math 200 or Elementary Algebra Midterm Review. Okay, let's take a look at this one. Simplify 7 plus 8 times 6 minus 3. Order of operations tell us that multiplication has precedence, so we'll begin by multiplying 8 times 6. That's equal to 7 plus 48 minus 3. Now we can work from left to right as we only have addition or subtraction left. 7 plus 48, that's 55, and 55 minus 3 is 52. Now this is an algebraic expression, but we follow the same idea. We want to crunch these terms together to make this expression as simplified as possible. And here we begin by distributing 8 into the parentheses. The 15 minus 11x stays the same, plus 8 times 7x, that's 56x, and 8 times negative 3, that's minus 24. Now we need to combine terms, and I'd like to combine the variables first. Negative 11x plus 56x, negative 11 plus 56, that's positive 45. So we have 45x. Combine the constant terms. 15 minus 24, that's negative 9. So this simplifies to be 45x minus 9. Here's a linear equation, and we want to isolate the variable. We look at what's attached to the variable. Here we're subtracting 7. How do we undo subtracting 7? We do that by adding 7 to both sides of the equation. Remember, you need to do the same thing on both sides of the equation. Negative 7 and positive 7 combine to be 0. On the right side, negative 13 plus 7 is negative 6. So our solution is x equals negative 6. In this linear equation, what's attached to the variable? Negative 6. How is it attached? Negative 6x implies multiplication. How do we break multiplication? Through its inverse operation, division. We'll divide both sides by negative 6. Negative 6 divided by negative 6 is 1, leaving only x on the left-hand side. Now on the right-hand side, that does not divide evenly, so we need to reduce this to lowest terms. We know there's a common factor of 2. 32 divided by 2 is 16. 6 divided by 2 is 3. And because we had one negative sign, this is a negative solution, negative 16 thirds. This linear equation is a little more complicated. We have both a 3 and a 17 attached to the variable. We begin by isolating the variable term. In other words, we want the 3x to stand alone. How do we break addition of 17? With subtraction. 17 minus 17 is 0. Negative 16 minus 17 is negative 33. And now we can divide both sides by 3, leaving x isolated. Negative 33 divided by 3 is negative 11. So our solution is negative 11. To solve this linear equation, we want to begin by simplifying both sides completely. And that means we need to begin by distributing 5 into the parentheses. 5 times 2x is 10x, minus 5 times 3 is 15, minus 6 equals 4x plus 27. Now on the left-hand side, we have two like terms that we just simply combine the way they are. Negative 15 and negative 6 combine to be negative 21. Copy everything else down. Now I want to collect all the variables on one side, and I'll collect them on the left side by subtracting 4x. 10x minus 4x is 6x, minus 21 equals 27. Add 21 to both sides, and we get 6x equals 48. And when we divide both sides by 6, we're left with x equals 8. So 8 is our solution. Here we have a linear inequality, and we solve these just like linear equations unless we have to multiply or divide both sides by a negative number. Begin by isolating the variable term, add 9 on both sides. We get 5x is less than or equal to 30, and I'm going to divide both sides by positive 5 so I don't have to change the direction of the sign. I'm left with x is less than or equal to 6. Now before we go looking for interval notation, it's a good idea to get this onto the number line. I'm going to make a mark at 0. 6 is somewhere to the right of that. We need to determine if our circle at 6 is going to be open or closed. Because of the equal sign, that's going to be a closed circle at 6. Which direction do we shade? Less than, the values of x that are less than 6 are to the left, so we shade to the left. Now we do need interval notation that's read from left to right. The left arrow indicates that we have negative infinity. On the right side it stops at 6, and at 6 is included, so that gets a square bracket. In this compound inequality, we want to isolate x in the middle branch. So we'll begin by adding 3 to all 3 branches. Negative 9 plus 3 is negative 6. That's less than 2x. And that's less than 5 plus 3, or 8. Finish by dividing out the 2. Negative 6 divided by 2 is negative 3. Less than x, less than 4. So we're looking for values of x that are both greater than negative 3 and at the same time less than 4. Or in other words, we want x to be between negative 3 and 4. So on the number line, there's 0, negative 3 to the left, 4 to the right. What kind of circles will we have? Well, there's no equal sign, so these are going to be open circles, and we shade between those. In interval notation from left to right, that's negative 3 comma 4. Are either value included as a solution? No, so we use parentheses. In this word problem, I see that there are 2 unknowns. We have one number and another. So I'm going to list my unknowns here to the left. Number 1 and number 2. It says that 1 is 13 less than another. So if we let the first one be x, what is 13 less than that? Well, that's x minus 13. Be careful not to write that as 13 minus x. When we say 13 less than, that tells us to subtract 13. Now the next sentence gives us our equation. It says 6 times the smaller number is added to 5 times the larger number, and that sum is 153. I need to know which of these 2 unknowns is the smaller number and which is the larger number. We know that subtracting 13 makes a number smaller, so x minus 13 is the smaller number and x is the larger number. We can substitute those in. 6 times x minus 13 added to 5 times x equals 153. Now we have an equation to solve. Distribute 6x minus 78 plus 5x equals 153. Combine like terms. 11x minus 78 equals 153. Isolate the variable term by adding 78 to both sides. 11x equals 231. And finish by dividing by 11. That leaves us with x equals 21. Now that's not the end of the problem, but we take that value back to our original table. X is 21 tells us that the larger number is 21. The smaller number is x minus 13. And 21 minus 13 is 8. So the numbers are 21 and 8. To find an x-intercept, we need to determine what x is equal to when y is 0. Remember, always, whichever intercept you're looking for, let the other variable be 0. So if I put in 0 for y, 5x minus 4 times 0 equals negative 40. 4 times 0 is just 0. So that leaves me with 5x equals negative 40. Basically, I'm ignoring the y term completely. Divide both sides of this equation by 5, and we get x equals negative 8. As an ordered pair, x comma y, that's negative 8 comma 0. For the y-intercept, we let x equal 0. 5 times 0 minus 4y equals negative 40. Don't lose that negative sign. Negative 4y equals negative 40. Divide through by negative 4, and we get y equals 10. As an ordered pair, x comma y, x was 0, y was 10. To find the slope of a line that passes through 2 points, we need to know the slope formula, and that is m equals y2 minus y1, the second y coordinate minus the first y coordinate, over x2 minus x1, the second x coordinate minus the first. We should go ahead and label these points as x1, y1, and x2, y2, so that we can substitute into our formula. In this problem, y2 is 1 minus y1 is 6. Notice we're subtracting the y values in that direction. We'll need to subtract the x values in the same direction. That's 5 minus 2. 1 minus 6 is negative 5. 5 minus 2 is 3. That is the slope. When we're looking for the slope and the y-intercept of a line, that's telling us that we need to get this equation into y equals mx plus b form. And that means we need to isolate y on one side of this equation. So we'll begin by subtracting 9x from both sides. Now, we cannot combine 42 and negative 9x, but because we want it to be in mx plus b form, I'm going to write the x term first. So we have negative 9x plus 42. Now we finish solving for y by dividing both sides by 6 and simplifying. Negative 9 over 6 reduces to be negative 3 halves plus 42 divided by 6 is 7. I know that my slope is negative 3 halves, and I know that my y-intercept, b is 7, so that is at 0, 7. To graph this line, we notice that it is in y equals mx plus b form. The y-intercept is at 5, so we can start there. The slope is negative 4, and that tells us that the line moves down 4 units as it moves to the right by 1. So from that point, I count down 4 and over 1, and then I'm just going to draw the line that passes through those 2 points. You should be using a ruler, make sure that's straight. Here's another line. Again, this one is in slope-intercept form. The slope is 2/5 and positive, which means that it's going to be moving up 2 as it moves 5 to the right. And here b is negative 4. That slope is our starting point. We're going to put a point at negative 4 on the y-axis. Again, that slope of 2/5 means up 2, right 5. So up 2, 5 to the right, and then we just draw the line that passes through there. When an equation is in this form, it's best to graph it by finding its intercepts. To find the x-intercept, again, that's where y equals 0. That creates the equation 6x equals negative 18. When I divide both sides by 6, I get x equals negative 3. So I have an x-intercept at negative 3, 0. Put that on the graph. For the y-intercept, that's where x equals 0. That leaves me with the equation negative 2y equals negative 18. divide both sides by -2, and I get y equals 9. So that's the point 0, 9, 9 on the y-axis, and then we draw the straight line that passes through those 2 points. This graph's a little different. This is an inequality, so this means after we graph the line, we have to shade half of the plane. Let's start with the x-intercept. The x-intercept is where 4x is equal to 24. Divide both sides by 4, and we find that that is x equals to 6. So there's a point at 6 on the x-axis. Next, the y-intercept. That is where 3y is equal to 24. Divide by 3, and we get y equals 8. So that's 0, 8. We have an intercept at 8 on the y-axis. This line is going to be solid, not dashed, because of the equal sign. So we begin by drawing a solid line through those 2 points. And I have to figure out whether I'm going to shade to the bottom left or the top right. I pick a test point, a point not on the line, 0, 0. I plug that into the original inequality. That's 4 times 0 plus 3 times 0, and I want to see if that's less than or equal to 24. Well, this whole left side becomes 0. Is 0 less than or equal to 24? Yeah, it is. That's true, and that means that 0, 0 is a solution, and all the solutions are going to lie on to the left and below this line, like so. If that value had been false, I then would have switched out to this side instead. Evaluating a function tells us to substitute a value in for x and see what we get. F of -4 is 9 times -4 minus 20. Now it's an order of operations problem on the right-hand side. 9 times -4 is -36, and -36 minus 20 is -56. So f of -4 is -56. In this problem, we're looking for an equation, and there are really a couple of ways that we can do this. One is using the point-slope formula. Y minus y1 equals m times the quantity x minus x1, or we could do it using the slope-intercept form. Y equals mx plus b. And I'm going to run through this both ways with you. First, I notice that 6 is my slope, and using the first format, 8 is x1 and -7 is y1. So I'm going to substitute into this form y minus y1, that's -7, equals m, which is 6, times x minus x1, which was 8. Now I just have to solve for y. Distribute the 6. Notice that minus -7, I can rewrite this as y plus 7. Distribute 6, that's 6x minus 48. And I need to subtract 7 from both sides. Y equals 6x minus 55. Now if I switch over to the slope-intercept form, instead of x1 and y1, I'm going to treat these two as x and y. So I replace y by what it's equal to, -7. I replace m by what it's equal to, 6. I replace x by what it's equal to, 8. And I need to solve for b. 6 times 8 is 48. And to find for b, I subtract 48 from both sides. -55 equals b. So to come up with an equation of a line, I need two numbers. I needed the slope, which I just found, and the y-intercept, which I just found. Now I can just rewrite that as y equals 6x minus 55, which you'll notice is exactly the same either way. We know that two lines are parallel if they have the same slope. We know that two lines are perpendicular if their slopes are negative reciprocals. Otherwise, the two lines are neither parallel nor perpendicular. The first equation is already in slope-intercept form, so I know its slope is 7/3. Now I need to find the slope of the second equation by isolating y. I'll begin by subtracting 6x from both sides, leaving me with 14y equals negative 6x plus 84. Divide away the 14 to solve for y. Y equals, okay, to simplify negative 6 over 14, I can divide a common factor of 2 out. That leaves me with negative 3 over 7x. And even though I don't need it here, I'm going to find the y-intercept. 84 divided by 14 is 6. So this slope is negative 3/7. Okay, back to parallel. Are the slopes the same? No. Positive 7/3 and negative 3/7 are different, so we know the lines are not parallel. Are they perpendicular? Well, that means that they would have to be negative reciprocals. 7/3 is positive, negative 3/7 is negative, so we have negative or opposite signs. And are they reciprocals? Sure. 7 over 3 as a reciprocal is 3 over 7, so that tells me that indeed these two lines are perpendicular. By the way, we do or can denote that using this symbol, an upside down capital T. Okay, now we're into the chapter on systems of linear equations and two unknowns. This problem is best solved using the substitution method because I have y already isolated in one of the equations. That tells me that I can substitute for y in the other equation. Because y is the same as 5x plus 4, it can be 5x plus 4 here as well. So I make the substitution. 7x minus 4 times whatever y was is equal to 10. And here's where I'll put 5x plus 4 in for y. Now I have one equation with one unknown that I can solve. Distribute the negative 4. 7x minus 20x. And then finally, negative 4 times positive 4, that's minus 16, equals 10. Combine like terms. 7x minus 20x is negative 13x. Isolate the variable term by adding 16 to both sides. Negative 13x equals 26. Divide both sides by negative 13, and I get x equals negative 2. Now you want to be careful here because we're trained once we have x equals some number to stop, but we're not done. We're only halfway there. I need to take that value of x, negative 2, and find out what y is equal to at that point. So I'm going to use the equation I substituted with. I'm going to replace x by negative 2. 5 times negative 2 is negative 10, and negative 10 plus 4 is negative 6. So, sorry about that. That was fun. So y equals negative 6. And my solution as an ordered pair then is negative 2, negative 6. I can check this into the second equation. If I replace x by negative 2 and y by negative 6, that second equation must be true. 7 times negative 2 is negative 14. Negative 4 times negative 6, that's plus 24. Is negative 14 plus 24 equal to 10? It is. So our solution checks. Negative 2 comma negative 6 is our solution. Here's a system that's best solved by the addition or elimination method. Notice that the two terms containing y are opposites, so we can add these two equations together as is. 6x plus 5x is 11x. 7y minus 7y is 0, so I don't need to write anything there. 69 plus 19 is 88. Now I can solve for x by dividing both sides of the equation by 11, and I get x equals 8. Now I can come back to either equation. I'm going to use the first equation because the coefficients are both positive, but it doesn't matter. 6 times the value of x, which is 8, plus 7y equals 69. 6 times 8 is 48, so I'm going to subtract 48 from both sides, and I get 7y equals 21. Divide through by 7, and I find that y is equal to 3. So my solution is the ordered pair 8, 3. If you want to check, as we did in the last example, you can check in the second equation, and you'll find that 8, 3 is the solution. Here in the system of equations, x and y are both on the left side in both equations. This is typically a good indicator that you should use the addition method. I look at the coefficients for x first, and I look to see if the smaller coefficient 5 divides into the larger coefficient 9 evenly. It doesn't. That means to eliminate x, I would have to multiply twice. Same problem happens with y. 3 does not divide into 4 evenly, so I'm going to have to multiply both equations by a number first. I'm going to work with the y's because I have one positive and one negative coefficient. I need to figure out what do 3 and 4 both go into evenly, and that's my goal. My goal is to get positive and negative 12y in those two equations. I can accomplish that by multiplying the top equation through by 3. 9x times 3 is 27x, plus 4y times 3, that's 12y, equals 41 times 3, or 123. I can get negative 12y by multiplying the second equation by 4. 5x times 4 is 20x. Negative 3y times 4, that's negative 12y, equals negative 19 times 4, or negative 76. Now we can add these two equations together. The y terms will cancel, and we're left with 47x equals 47. Divide both sides by 47, and we get x equals 1. Now we still need a y value to go with it, so I'm going to go back to the first equation. I'm going to put in 1 for x, so 9 times 1 plus 4y equals 41. 9 times 1 is just 9, so I can subtract 9 from both sides. 4y equals 32. Divide both sides by 4, and I get y equals 8. So my solution is the ordered pair 1, 8. If you have time on your exam, you really should check it in the other equation. And if you plugged it in here, 5 times 1 minus 3 times 8 does equal negative 19. Here's another system of equations. I have y isolated, so that tells me to use substitution. I'm going to substitute for y in the second equation. So 8x minus 2 times whatever y is equal to negative 10. I substitute 4x minus 5 for y, and now I can solve. When we substitute, the first move is typically to distribute, and we'll do that here. 8x, negative 2 minus 4x is negative 8x. Negative 2 times negative 5, that's positive 10, and that's equal to negative 10. Notice here that 8x minus 8x is 0, so those terms disappear, leaving us with 10 equals negative 10. When all the variable terms disappear, whether you're using substitution or addition, you either have a system that is inconsistent with no solution, or is dependent with infinitely many solutions. And it's all about whether that resulting equation is true or false. Since 10 is not equal to negative 10, no matter what x and y are, then there is no solution to this system. This is an inconsistent system. And if we were to draw graphs for these two lines, what we would notice is that they would be two distinct parallel lines, not crossing. This word problem is an example of a typical coin mixture kind of problem. We have two items, each worth a different amount. Here, what we have are adults and children. So I'm going to use the variable a to represent the number of adults and c the number of children. And I need to find two equations here. First, I know that there were a total of 107 people. That means that if I add up the number of adults and children, that has to equal 107. The second equation comes from the total amount of money raised, $732. How much money was raised from the adults? Well, each adult paid $9. So that's 9 times the number of adults, added to the amount of money paid by children, and that was $6 for each child, 6c. That has to equal 732. We'll go ahead and solve this system on the next screen. Now, we could solve this system by substitution, getting a or c by itself. But in general, when the two variables in both equations are together on the left-hand side, I like to use the addition method. Here, I'm going to try to make the c term into the opposite of 6c, and I can do that by multiplying the top equation by negative 6. So that's negative 6a minus 6c equals negative 6 times 107. That's negative 642. I'm going to copy the second equation over. 9a plus 6c equals 732. And I can go ahead and add those two equations now. Negative 6a plus 9a, that's 3a. Negative 6c plus 6c cancels, equals negative 642 plus 732, that's 90. I can solve for a by dividing both sides of the equation by 3, and I get a equals 30. Now I can substitute back into either of the original equations, but I know that there were 107 people total, so the number of children has to equal 107 minus the number of adults, 30, which is 77. Now a quick check of 30 adults and 77 children. The adults paid $9, and 30 times 9 is $270. The 77 children paid $6 each. 77 times 6 is $462, and when I add these together, I get $732, which was the total amount. So everything checks. There were 30 adults and 77 children. Here's the last word problem. It involves the perimeter of a rectangle, and so we need to know the formula. 2 times the length plus 2 times the width equals the perimeter. There are two unknowns in a problem like this. The length of the rectangle, which we'll use the variable L for, and the width of a rectangle, which we'll use the variable W. We're told first that the perimeter is 158 feet. So 2 times the length plus 2 times the width is 158. The second equation comes from the fact that the length of the slab is 27 feet longer than the width. The length is 27 feet longer than, that tells me to add 27. Add 27 to what? The width. So there's our system. We'll solve that on the next screen. Okay, here we are. This is set up for substitution. L is the same as W plus 27, so that can go in for L in the first equation. 2 times whatever the length is added to 2 times the width is 158. I can replace the length by w plus 27, and now I can solve. Begin by distributing. 2 times w is 2w, plus 2 times 27, that's 54. Copy the rest down. I can combine the like terms. 2w plus 2w, that's 4w. Copy everything else down. Isolate the variable term by subtracting 54 from both sides. 4w equals 104. Solve for w by dividing by 4, and I get w equals 26. In this problem, the units were feet, so the width is 26 feet. I still need to know what the length is, and for that, I'll go back to this equation that I used to make the substitution. The length is 26 for w, plus 27. Adding those together, I get 53 feet. And there's my solution. The length is 53 feet, the width 26 feet. I hope this has helped you out. If you've made it this far, congratulations. If you have any questions, you can go ahead and contact me through my website, georgewoodbury.com. There's a contact form on that page. Also on Twitter, you can track me down, my username at George Woodbury. If you have questions, comments, other videos you'd like to see, just drop a line. This is the first time I've used Explain Everything. I hope this works out well for you. Good luck.